I welcome all the students. Today we are going to discuss the topic 3D rotation. Okay, in the previous session we have already covered the 3D translation part. We have started with learning the 3D transformation, under which uh, last session we have learned 3D translation. So today's topic of discussion is we are going to learn about the three-dimensional rotation. We're going to learn about the 3D rotation part. Okay, so this is the syllabus that we are having. We will cover this point after this session. Okay, let us start our discussion about the three-dimensional rotation, how it is applicable to the 3D dimensional rotation. We have seen 2D rotation. Okay, similarly we are going for the three-dimensional rotation. Okay, let us start our discussion. Now for 3D rotation, to generate a rotation transformation, okay, to generate a rotation transformation for an object, what we have to specify, we must specify an axis of rotation. Okay, so I must specify that I want to rotate about the x-axis, I want to rotate about the y-axis. Okay, that is about which the object is to be rotated. We have to first find out, or the input which is given or which is expected is, we should specify the axis of rotation, and then we have to specify the angle of rotation. Okay, I want to rotate by 90 degree, 180 degree, 45 degree, and along with I have to give also the axis of rotation. So I want to rotate about x-axis, I want to rotate about the y-axis, I want to rotate about z-axis, and so on. Okay, so these are the two input that we need to give. Okay, now generally whenever I'm giving the angle of rotation as an input, okay, theta value I'm giving as a rotation input, then we must know what is the positive angle of rotation and what is negative angle of rotation. Okay, so when I give plus 90 degree, minus 90 degree, so what is the positive and what is negative angle of rotation? So here we are considering the positive rotation angle produces, okay, so here we are considering positive plus angle plus 90 degree. If I'm giving, then it produces the counterclockwise rotation or anti-clockwise rotation. So positive rotation angle indicate I want to rotate the object in a counterclockwise direction, or I want to in a anti-clockwise direction. Okay, about the coordinate axis, whatever the axis I have specified. Okay, if you are looking along the positive half of the axis, okay, so if I'm looking along the positive half of the axis towards the coordinate origin, okay, then it is going to specify the angle of rotation. Okay, positive angle of rotation. To understand this, let us consider one diagram which will clear the concept of positive angle of rotation and how it is applicable in the 3D rotation. Okay, so let us understand this. Now here you can find this diagram. In the diagram, what we have mentioned is the positive rotation directions about the coordinate axis are counterclockwise. I think I have mentioned the same point over here. Positive rotation angle produces about the coordinate axis are counterclockwise. When looking toward the origin, what we have to do, we have to look toward the origin from the positive coordinate position on each axis. Okay, now we want to show in this particular diagram is, okay, so suppose I considered here the diagram number A. Okay, then suppose this is my z axis. So in the diagram number A we are talking about the z axis. So this is my z axis now. So this is, I am looking from this, so this is the angle that we are looking towards it. Okay, so this is the human being, so this is my eyes and I'm looking to this particular direction. You can find it into the diagram. So this is my looking to angle of direction, I'm looking in this particular direction here, okay, towards my origin. This is my origin. Okay, then in that particular case you can find it, what will be my angle of rotation for the z axis, which is my positive angle. Then you can find that this is my positive angle, this is my arrow. Okay, positive angle. Similarly, in the B diagram, if I'm talking about x-axis, okay, so I'm looking towards the x-axis, okay, then you can find what was the angle of rotation positive angle of rotation for x-axis is this to this side. Okay, you can find the arrow over here. So this is my arrow. So I'm looking this to this axis, this to this rotation was my positive. Similarly for the y-axis, okay, so this is shown over here. I'm looking from this particular angle, and my angle of positive angle of rotation will be in this direction. Okay, so this was my direction. Okay, so I repeat it again. For y, my positive angle of rotation is I am moving from this to this side. Getting me? For x-axis positive rotation, I am just moving from this to this side. Okay, and for the z-axis, you can find I am moving from this particular to this side. Okay, so this was my positive angle of rotation. Okay, so definitely we are considering more diagram to understand this, but this is what the basic way of understanding the 3D rotation about x-axis, y-axis and z-axis, and which should be considered as a positive angle of rotation. Getting me? I'm just continuing our discussion of 3D rotation. I think this is what the basic we are having. Okay, but definitely we have to consider the matrix representation of 3D also, that how we can represent the 3D transformation matrix for the 3D rotation. Okay, so continue our discussion. I just move to the next slide. Now the 3D rotation about x-axis. See here, as we have seen at the time of 3D translation, my object is represented, my point is represented in 3D space by x, y and z axis. So we have to consider the rotation about x axis, y axis as well as the z axis. Getting me? So the 3D rotation about x axis, okay, what will happen? The x coordinate of the position vector does not change. Okay, so x coordinate of the position vector is not changing if I am going to rotate about x axis. Okay, so then I'm rotating, in this case, the transformation matrix that I'm having. Let us understand what will be my transformation matrix with the angle theta. Okay, so I'm considering this angle theta for the we are considering it as about the x axis. Okay, about x axis that I'm having. Okay, so let us consider the matrix, transformation matrix for this. So this is my transformation matrix. Okay, you can find this transformation matrix, okay, for your understanding, as it is about x-axis. I think there is no need for me to when we go for y and z axis, but as it is our first transformation matrix of 3D rotation about x-axis, I considered, okay, obviously everyone knows this is my x value. Okay, this is going to be your y value, this is going to be your z value, and this is h. Okay, so I'm considering for row wise, this is my x value, this was my y value, and this was my z value. Okay, so if I consider this, what we have to do, the x coordinate of the position vector does not change. So you can find this is xx, it is having not changing, it is having the value 1. Getting me? This is having this value 1. Okay, and xx diagonal values is 1, and remaining values of x you can find it having the value 0 0 0. So this is the column related to x. See what I'm saying? This is the column related to x. It is having the diagonal value, it should be 1, but remaining values are 0 0 0. This was my row about x axis. Getting me? Diagonal value is 1, this is 0 0 0. Getting me? About x axis. Okay, so that is what we have written. 3D rotation about x axis, the x coordinate of the position vector does not change, so all the values are 0 0, but the diagonal value should be 1. Okay, so that is what I have mentioned. Now for remaining values, okay, we are already knowing in 2D rotation, the formula I will get it as the cos theta and sin theta. I think we have seen this was my transformation matrix in 2D. So this value will be, if I consider the second row y, this value is y into y, it is cos theta sin theta minus sin theta cos theta. Okay, obviously this is the diagonal value which is 1, all remaining values are 0 0 0. So this was my 3D rotation about x-axis transformation matrix, and just to I consider the angle is theta. So I'm having cos theta sin theta minus sin theta and cos theta. Okay, now to understand this, now before moving to the further 3D rotation about y-axis, z-axis, I think we should consider this something which is very important. So I just read this point. The rotation is assumed positive. Okay, my rotation angle is assumed positive in right hand sense. okay, in right hand sense, that is clockwise as one look outward from the origin in the positive direction along the rotation axis. Okay, my rotation is assumed positive in the right hand sense. Okay, now what is this right hand sense indicate? We should consider the right hand thumb rule for this. Okay, everyone knows about right hand thumb rule. So according to, so this angle of rotation is positive direction according to the right hand thumb rule. Okay, so let us understand what is this right hand thumb rule. Okay, everyone already knowing about the right hand thumb rule, so let us understand. So I'm just describing here what is my right hand thumb rule. Align the thumb of the right hand with the positive angle of direction. So I'm align my thumb. Okay, so thumb of your right hand, you have to align the thumb into the positive direction, okay, of the rotation axis. Then the natural curl of fingers, okay, then the natural curl of fingers. See, I just want to show it here. Okay, so I know that in the video it is not that much easily visible, but I just showing that this is my right thumb. Okay, this is my right thumb. I want to put this right thumb into the angle of direction. So for example, this is x, I consider, so this is my x direction, getting me? If it is y direction, this is y, this is z. So suppose I consider my angle of my right direction is this x. Okay, so align the thumb of your right hand, align the thumb of your right hand in the positive direction of the rotation, and this is my natural curl of fingers. Okay, so this is my natural curl of fingers. So if my object is there and it is rotated in this way, this is because this is my natural curl of fingers and this is my angle, positive angle that I'm going to put. Okay, then the natural curl of these fingers gives me the positive direction. Okay, you just apply, if you want to show it, see it practically, you apply this to any one object and see that the natural curl of finger will be positive, and the reverse case definitely it will be the negative angle of discussion. Okay, so you can just consider it as one of the example applied to any object or the book, then you can understand what is the positive angle of rotation and what is the negative angle of rotation. So all these are depends, why? Depends on the right hand thumb rule. Okay, and just I have explained what we have to do. Align the thumb of the right hand with the positive direction of the rotation axis, and the natural curve of fingers will give the positive rotation direction. Okay, it is giving you the positive rotation direction. The natural curve of fingers gives the positive rotation direction, and considering this, I am finding my positive. So that's why we have written rotation is assumed positive in a right hand sense. Okay, so that is what it is applicable. So with this basic discussion, let us start understanding about the 3D rotation, about the remaining two axes, z axis and y axis. Okay, we have considered this was the transformation matrix for the 3D rotation. About x axis, I have explained this that x should not change. So this is my x column, this is my x row. Okay, so diagonal value is 1, but all the remaining values I am having it as 0 0 0, and for this I am having this cos theta sin theta value. Okay, so let us continue our discussion for 3D rotation about the y axis, okay, and z axis. Okay, now in similar manner, the transformation matrix for rotation by angle phi, okay, only we are just changing the symbol for our understanding. Instead of theta, we are just taking the phi, which is different symbol. About the y axis is, okay, now again I am just repeating the same thing. This is my transformation matrix for the rotation about y axis. Okay, 3D rotation about y axis. Okay, now we can find it here. Similarly, as I said, this is my x value, this was my y value, this was my z value. Again, this is my x value, this was my y value, and this was my z value. Similarly, the y value should not change. You can find this was my column for the y, sorry, row for the y. This is my row for the y. Diagonal value is 1 because this is y value is 1, remaining 0. And this was my column for the y. We should have the value 0 0 0. Diagonal is only 1, and remaining I get it as cos phi minus sin phi, and cos phi. Okay, actually in the previous discussion related to x and z, I get this value cos phi. Here it is sin phi. Here it is minus sin phi and cos phi normally. as per my equation. Okay, but here you have to remember the change here is I am having this cos phi. This is not plus sine phi. This is minus sine phi. Okay, now why I have set this value to minus sign and this is positive sine phi, just to maintain the right hand thumb rule. That's why I have explained you the right hand thumb rule. Okay, so this was my matrix for the 3D rotation about y-axis. That is what I have mentioned here. Note that the signs of the sine term, okay, you can find it here. The sine phi sine phi value are reversed, okay, to maintain the right hand thumb rule. By normal case, I'm having this is cos phi sin phi, this is minus sin phi cos phi, but here this sin phi and these values are interchange. Okay, so what I'm saying, these values are interchange just to maintain the right hand thumb rule. Okay, to maintain this, these values are changed. Let us now understand the 3D rotation matrix about z axis. Okay, so I'm just explaining here for rotation angle phi, only the symbol had changed just to understand the different way for the z axis. So rotation angle phi, again we say about the z axis is, okay, you can find here, this was my transformation matrix, 3D rotation transformation matrix about z axis. Similarly, as I had told here, the value of z should be 0 or it should not change. So this is my x, this is my y, this is my z. You can find this is my x, this is my y, this was my z. What is the row that I'm having for the z? 0 0 0. This z to z is diagonal term, so only the diagonal term value is 1. This is also diagonal, so it is 1. This was my z column having the value 0 0. All values are also 0. And now I will apply cos phi sin phi minus sin phi cos phi. Okay, so this is correct. Cos phi sin phi plus sin phi minus sin phi cos phi. This is similar for the z. Okay, it is similar for the x also. X also we are having the sequence cos phi or cos theta sin theta minus sin theta and cos theta. Only for the y, okay, we can find the difference here. Only for the y, cos phi minus sin phi is there, and then I'm having the sin phi and cos phi. Getting me? So why only for y there is a change? The signs of the term, the plus and minus signs of the sign term are reversed only to maintain the right hand thumb rule. Okay, so remember the 3D rotation matrix. Okay, 3D rotation matrix about the, I think we have seen in previous slide about x-axis. This is for y-axis and this was for z-axis. Getting me? So this is the very important term related to 3D rotation. Okay, let us continue our discussion of the 3D rotation, so that we have to consider the example as well as with the help of diagram how exactly the object is rotated in the 3 dimension. Okay, so I'm just moving to the next slide now for the further discussion. Now here what we have written is the following diagram illustrates 3D rotation of an object about x and y axis. Okay, similarly in the next slide we can see about the z axis also. Now whatever I am showing here, that is just for your understanding purpose, to understand how it is rotated, how the object was rotated. Okay, how it will look like, how it is visualized. Okay, so that's why I am just showing you these diagrams. Okay, now you can find it here. Okay, the first one, the rotation of an object about x-axis. Okay, about x-axis I'm going to rotate. Okay, so where I am having the x-axis, yes, you can find it here. See, this is my x-axis. Okay, this is my x-axis. This was my original object. Okay, you can find the object over here. Maybe it is little bit blur, but it is visualized. This was my object. And what was my angle of rotation about x-axis? So this is my angle of rotation about x-axis, and the object will move in this direction if I rotate it by 90 degrees. So I'm just considering it as the 90-degree rotation. This was my original object. Okay, it is moved into this direction. Okay, that is the rotation about the x-axis, because this is my x-axis and it is moved, and the object will, suppose I move in 90 degree, my object will appear somewhere here. Okay, it is look like something this. Okay, now this is just for your understanding. We will see one more example also to understand the things in detail. Okay, so just considered about the y-axis how the object will look like. Okay, so that's why I'm having this particular diagram. So this diagram shows the rotation of an object about y-axis. okay, about y-axis. So which was my y-axis of angle? This is my y-axis. Getting me? This was my y-axis. Okay, now for y-axis, assume what I'm saying, this was my original object. Okay, so my object is this original object. If I rotate about y-axis, so this was my angle of rotation. Okay, so this indicates the angle of rotation, and here my object will appear. Okay, if I rotate it about the y-axis, considering this rotation, I think we have seen something like this in the previous diagram also. So this was my angle of rotation. So the object will move from this direction and it will appear over here if I am rotating the 3D object about y-axis. Okay, so this is what, just for your example or purpose of the understanding. Okay, so let us move about and also see the one more diagram, how the object will look like if I am going to rotate the 3D object about the z-axis. Okay, about z-axis. So let us understand this diagram. Following diagram illustrates the 3D rotation of an object about z-axis. Okay, now here you can find the way the object has moved. You can find this was my z-axis, rotation of an object about z-axis. This was my angle of rotation. Okay, so this is my z-axis. This was my original object, okay, which is here. Okay, and when I rotate this particular about this axis, actually this I have shown here, this is my angle that I'm having. My object will appear somewhere here. Okay, so this is something which is related to, or whatever we are considering about the, these are just the example, okay, normal example. Here I have not considered the matrix representation of the object. Okay, we have shown only that how this particular object will be, how this particular object will be moved, okay, in this particular way, just for the purpose of understanding. Getting me? How it will be 3D object is rotating in x, about x-axis, about y-axis, and about z-axis. How and how it will look like, how it will appear. Okay, for that particular purpose only, we are having this diagram for understanding. Okay, but I know this is not sufficient. We should consider one object which can be represented in the matrix form. Okay, we have to represent that object in the matrix form. Suppose it is having the ABCD vertices, then we have to represent it in the vertices ABCD, and appropriately we have to show how it will looks like. Okay, how after rotation, how it will be shown or how it will be look like. Okay, so that's why I'm considering, I'm moving to the next example so that it will be more easy for you to understand. Okay, so that this is, we have already seen the transformation matrix. Okay, so what we have to see, we have to consider one object. Okay, and then I apply the angle appropriately. I perform matrix multiplication and I will get the expected result, okay, for this 3D rotation. So I'm just moving to the next slide so that we can consider the example with the help of some correct object. Okay, so let us understand this. See, this is what I'm going to consider here. Okay, now I'm having the diagram shows the 3D rotation of original object A. Getting me? See what I have shown, this was my original object A. I think now it will be more easy for you to understand because we are having some transformation matrix can be easily represented in the form of A, B, C, D, E, F, G. I think we have seen already. Consider this is my one of the rectangle as my original object. Okay, I may have this having the value for 8 vertices. A, I think we have already mentioned it as A, B, C, D, E, F, G, H, I, and so on. But now instead of considering all these object, okay, instead of considering all these parameters, okay, I just consider for the simplicity, I take only one point here. Okay, I'm just going to take only one point here as this is my original object and having the point A. Okay, now suppose I want to find out what should be the value of this A. Getting me? I'm just doing it roughly. What should be my value of A? What is the X value? Okay, so let us check the scaling. Suppose I consider this is 1, this is 2, okay, and this is 3. Okay, so if it is the case, I think I'm getting this X value of the point A will be 3. Getting me? Suppose I consider this scale is 3. What is about Y scale? Suppose I consider Y, this is 1 and this was 2. So I think it has shifted over here. So I may have the Y value of this particular A point maybe 2. Okay, so this is my X value. this is my y value. Okay, I'm just considering this as my y value. And what is my z value? So z value, you can find it here for this point. What is the scale here? Suppose it is 1. This is 1, 2, 3. This is 1 and 2. Okay, this is 1 and 2. And for z, it is only 1. So 3, 2 and 1, we can say. Okay, now what we are looking for, suppose I want to rotate this particular object about x-axis. Okay, I'm rotating this object about x-axis with the minus 90 degree. Okay, so here I'm having the angle of rotation as minus 90 degree. Okay, now in that particular case, what is going to happen? See, this is my x-axis. Okay, this was my x-axis. So this line is also x-axis. This all the lines which are belongs to x-axis, and I'm just keeping this as a fix. Okay, this is fixed, and from this x-axis, okay, it is minus 90 degree, it is rotated. See, if it is rotated minus 90 degree, I think my angle of rotation will be something like this. Okay, from here it will, so this object will go to backside. Okay, this object will go to backside. Okay, if this object go to backside, what will happen? I think this is the surface that I'm having. Okay, see what I'm saying? Suppose what is the bottom surface I'm having, that will come to the front side. That will be coming to the front side. So this will be the bottom which I'm having. I just shown over here. That will be come to the front side. The object will be moved to the back side. Okay, considering the x will be fixed. X is fixed and it is moved to the back side. Obviously, if I'm moving this back side, my A object, my point A will be appear here as A star, and this is what we are here. So this comes to the back side, and I will get, this was my object B after the 3D rotation of the original object about x-axis. Okay, so what I have done about x-axis, I have done minus 90 degree rotation. Getting me? Now I'm just showing this you as one of the example. Okay, I'm not considering, I will not going to draw the diagram for it, but just I'm considering it as, suppose this is plus, it is minus 90 degree. Instead of minus 90 degree, suppose I could have taken it as a plus 90 degree. Getting me? Plus 90 degree. What will happen? My angle of rotation will be from this to this side. Okay, my angle of rotation will be from this to this side. Okay, and what will happen? The object will be moved to the front side at this side, and so this A point will become here somewhere here. Getting me? The A will come or move to the front side, so it will become here somewhere here, and I will get my original object, something like this. It is clear? So it is not going to the back side, it will be come to the front side. Okay, so if I'm having the 3D rotation of this original object is shown in the diagram number A. Okay, so this original object 3D A, I'm going to rotate this object about x-axis. About x-axis means x value should be fixed. Now you will come to know that if my x value is fixed, so what value have changed? What should be? Suppose this is my A having the x value 3, y value 2, z value 1. What is the expected value of A star here? Yes, we can find out. What is the A value? What is my x value? X value will not change. So it will be 3 as it is. You can find here. For A point, x value is 1, 1 and 2. This is 1, this is 2 and this is 3. So the x value will not change. So this will be 3 as it is. Okay. But what is going to happen with the y value? Okay, if I consider the y value over here, okay, if I take, this is my 1 and this is 2, okay, you can find it here, this is x and y and 1 is 2. I may have the y value is 2 as it is, no issue. But now this is the question, what is my z value? Okay, see, you can look at this particular extension of my z value. This is having, suppose I consider this is the value I'm having, this is 1, this is 2, suppose I'm having, so this is also 2 value, but it is minus direction, this is plus, so this will be a minus 1 value, this will be minus 2 value. Okay, because my object has moved to the back side. Okay, my object has moved to the back side. See here, one more important thing that I'm just considering here, the value of y, this is 1, this is 2, y value is 2, this is 1, but what is the height of this particular object is 1. So my y value of A star will be 1. Okay, x value will be 3, my value of y will be only 1. See, consider I'm getting this value as 1. But what about z? Z value we can find it has changed. So this is -1, -2. So this will be -2. Getting me? So my A star, okay, so my object A star or A dash has appeared, okay, which was initially here having the value 3 to 1 plus 3 plus 2 plus 1. After rotating the object about x-axis with -90 degree, okay, my object will be sent to backside keeping x as a fix. So my object has appeared here, my point on the object has appeared here as a star, getting me, as a star. And now I have got the new values will be 3, x value will not change, so it is 3, y value is 1 now, but the z value is -2. Okay, so I hope all of you understood. This is all about show visually how the original object rotated about x-axis with -degree and how it will appear. Getting me? So let us understand the same original object if I am moving about y-axis. Okay, so let us understand with the next slide how it will look like if I'm going to move the object about y-axis. Because here in 3D rotation we have already learned the matrix, multi-transformation matrix about x-axis, y-axis, z-axis. Now in this slide we are just learning that how it will be visualized, how the object will be moved, to have a thorough understanding of the three-dimensional rotation. Okay, so I'm just moving to the next slide now to understand the point. Now you can find it here, the 3D rotation again, but now I'm having the diagram shows the 3D rotation of the original object. Same, just now we have seen the same original object. See, consider this was my original object shown in the diagram number A, and this was my point. Suppose I'm not considering all the point, I'm considering this my A point. Okay, this is my point which is represented as A. Getting me? And now I'm considering the its rotation about y-axis, okay, with plus 90 degree. Okay, plus 90 degree I'm rotating this particular object. Okay, so plus 90 degree if I'm rotating this object, again here the I think we have seen that to maintain the right hand thumb rule, the plus 90 degree rotation indicate that I have to move this. Now see, this is fixed now. Okay, my y value will be fixed now. So this y is fixed and I'm rotating this particular object in this way. Okay, because this is my y, so I'm moving in this particular direction. Okay, so what will happen again, this side is fixed, this side, okay, which is there. Okay, I'm just showing with the red color. This side will come to the front side, this will come to front. So see here, I'm having this side comes to the front, getting me, and the object is moved to back side, so this will goes to the back side. Okay, so object is moved in this particular direction. This was my y axis. I want to rotate the object about y axis plus 90 degrees. This will move to the back side. Okay, and if this is moving to the back side, where my A star will occur, yes, this is what my position of the point A star. A star will go to the back side. But now previously about x-axis this was fixed. Okay, x-axis when we have rotated this was fixed, but now I am rotating y-axis, so this side will be fixed now. Okay, so y value will be fixed, so this is fixed. Okay, and I'm angle moving, so this was my angle of rotation. Okay, so object will go to the back side, so this has go to the back side, and this was my A, which is front, go to the back side again, and this is represented as a star. Getting me? So it is, this clearly shows me, that is what I explained. This side which was my at, this considered y value, this is coming to the front side now. Okay, so object, this is coming to the front side, and I have rotated the object appropriately. Okay, and this is my plus 90 degree. If I'm considering if it is minus 90 degree, what will happen? If it is minus 90 degree, I think this object that I'm having this side will come to the front side. I think this was my angle of rotation, reverse angle of rotation about y-axis. So this was my minus, if it is minus degree, minus 90, so this object will come to front side. Okay, for minus 90 degree rotation. Okay, and maintaining the right hand thumb rule. Okay, so I consider this is all about the 3D rotation that we have learned. See, we have learned about the 3D rotation. Okay, first of all, we have seen which are the transformation matrix that we are having about x-axis, y-axis, z-axis. We have seen what is the right hand thumb rule, because that to maintain the right hand thumb rule, or right hand thumb rule gives us which angle is positive degree and which is negative degree. Okay, so that will, right hand thumb rule gives us the positive angle of rotation, and accordingly I think we have seen with the help of the different diagrams how the object will look like if I'm going to rotate the 3D object about x-axis, about y-axis, and about z-axis also. Okay, so this is what we have learned, okay, in our today's session of 3D rotation. Very interesting session to learn the 3D object, how it is rotated. Okay, I hope all of you have enjoyed the session. Okay, so we end our session here. Okay, thank you all of you. Thank you.